Hi, this is Michelle Wren, and tonight I'm going to walk you through my final project for MIS 5470, and that is Practical Computing for Data Analytics with Professor Iskin. So for my project, I chose project type 3, which was to use R or Python in an active Kaggle competition, and I chose to use R and enter the home prices in Ames, Iowa competition. The project involves taking data sets provided by Kaggle and predicting home values based on a ton of variables. And the goal of the competition, obviously, is to be the best at predicting the prices. My own personal goal, however, was just to get more comfortable with using R and manipulating data with it. So I will just take you through some of the highlights of this, since the first video I made was 20 minutes long, and we'll see if we can do this one a little bit shorter. Obviously, data pre-processing and exploration, extremely important. There were 79 variables in the group, and Kaggle gave you a great text file describing what all those variables were, which really came in handy. And I have given you a link to that if you would like to look through that closer. So I read in the data set two ways to see which would be closer to what I wanted. Read.csv ended up being the winner. This data had a lot of factored data, and read.csv read it in closer to what I needed it to be. So here's how it read it in. Basically, I chose to do that. I got rid of the first one, read in the test data. One thing that I had to keep reminding myself as I went through the project is every time you do something with your training data, you have to remember to do it to your test data, so that in the end, when you go to run your models, everything is happy. And so you will see train and test right next to each other throughout my documents. That is just so I didn't forget to do anything. I have a large area here with a lot of code. This is where I really went through the variables almost just about one by one. Like I said, lots of them were factors. There were quite a few variables where NA didn't actually mean it was null. It kind of meant that it was none. So I had to go through and recode. There were also many factors where they were ordinal, and so I wanted to give the program the information as to what I wanted that order to be. I did do some creating new attributes. I'm not sure if it's in this section or not, but for instance, remodel had a problem where if there was a remodel, it had a date in the column. If there was no remodel, then it had the date that the home was built. So I created a new variable for that one, just kind of a, has there been a remodel, yes or no. After I did all of that, I went through, did a little skim to see what I have. I still have some missing variables, which I kind of summarized down here. I went through, decided which ones I wanted to fix. Some of them I figured wouldn't end up in the final model, so I didn't fix those. This is just some more conversion after looking at that. I made a new variable combining the year and the month, but then I didn't end up using year-month variable. I ended up using year and month separately in my models, but just interesting, I did go ahead and make that. Exploratory data analysis, tons of variables, got to get rid of some. I love correlation. I don't know why. It's a sickness. So here is the correlation of all the numerical numbers. As you can see, I made kind of a data frame of just the numeric, and it's a ton to look at, but very useful for looking for correlation. Great for deciding if you can throw a new variable into your model or not. And then I have a picture. You could do something like this with Core Mat. A little hard to see because there's just way too many variables. But what I was really looking for was sales price correlation. So I used the package core, and you can isolate just one variable, sales price, and take all of the numeric data and see what your correlation is. So obviously there I was looking for variables with high correlation to see what I want to keep in. Through this document, I write myself notes as to what I think my keepers are for my variables. So if you see that, that's just what that means. This is just a little more EDA on the variables I'm liking so far. Then I started looking at the categorical information, which is, really cumbersome. First thing I tackled was the neighborhood. I ended up trimming this down. Instead of having 25 different neighborhoods listed, I ended up using some recoding to make a new variable where it was just 11 different choices. And just as a footnote, I tried them both in models, and they were pretty close to each other. So I ended up just using the new one that I created. This is old school code to recode. I tried to use if else or case when, and it was just not happening for me that night, so I just kept moving forward. I did run that Data Explorer report, which has a lot of information. I cannot find it right now, but I have a link for you to look at it. I kind of commented out the code because it takes a long time to run, and it doesn't need to be run over and over and over. So right here you can find that report if you want to look at it. Again, just more categorical data. I wanted to practice making different types of plots, all while trying to get a feel for if certain variables had an effect on the home price. This one was my favorite one. This is that year, month sold variable, and you can really see like how cyclical the housing market is with the highs and lows. I thought that one was pretty cool. Anyhow, more categorical data. Down here I noticed that I had some true missing values, which I replaced with the mean in 2 of these cases, and another one I just replaced with no. That was a categorical one. And the very last thing I did was normalize the data, the numerical data, that is. Then I saved these, wrote them to CSV files at the bottom of the file so that I could continue in a new file that I called Housing Ames Models. I started with 10 models, and then I went back and I threw a couple extra in. So that's why there's like 1 through 10, and there's a 6B and a 6C. So it ended up being 12 models. But anyhow, I took my training data from Kaggle, broke it into, read it in, obviously, broke it into training and model data for my use, and started with really simple models, and then kind of, in fact, here's my simplest, this one I was just trying to see if I liked using the first floor square footage, second floor square footage, or if I just wanted to use the total living area. First floor, second floor ended up being the winner there, so that's what I used from that point forward. But you can see I started out with an adjusted R-square of 76. And as I added in more variables, that kind of tightened down. Here I have 0.805. Here I have 0.8197. Towards the end, I started removing variables to see if that helped at all, and it did actually help one of the models. And you can certainly browse through all of this at your leisure, but I will take you down to the end Oh, I'm still doing models. See, removed months old, remove full bath. Interestingly enough, that ended up being my best model. Where it's just funny, it's counterintuitive. You would think the bathrooms would be a big deal, but removing it actually made my model better. So let's go to the end where I analyzed everything. I made files of the predictions from all the various models, and then I took those and I made a data frame. So the data frame here, you can see the first column is the actual, and then these are all my models that I built. And then I went and I calculated the R-squared for all of those. You can see here's all the R-squares listed. And I have a note here that models 6C, 9, and 10 were the best on training, but models 6C, 7, and 10 were better on the test data. I graphed some of them just to make sure that the data seemed normal, which everything seemed fine there. All the models were, really pretty consistent. And then, last but not least, I calculated the RMSE. That is what Kaggle judges the competition on, is the RMSE. So, my RMSE winner was Model 8, which actually turns out to be 6C. But you get to submit a ton of models to Kaggle, so I submitted 6 of them. And this is just the section where I created those for submission, wrote them to CSV files, and then here is what my results were on Kaggle compared with the actual test data. So my lowest one ended up being Model 10, which was 0.17398, which, not not the best, but it was, I think, here it is, 137 spots I went up, so that's not bad. And I have a lot of ideas of how I could still continue to improve the model. I could certainly see how this would be addictive. I might go back and try to tweak my entry a little bit over the next couple of weeks if I have time. But for as far as my presentation today, that's where I landed. So I'm in 4,087th place. Not great, but it was fun. So that is my entire project on housing in Ames and the Kaggle competition, and I hope you have enjoyed it. Thanks, bye.